Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You're looking at a live view of Falcon 9 awaiting liftoff at 5:30 p.m. Eastern Time from the Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Welcome to our live webcast of the USSF-124 mission on behalf of the United States Space Force and their partners. My name is Yo Mezo, and I'm a propulsion engineer here at SpaceX. I'm excited to be here with you today, bringing you coverage of our 13th launch this year, and the first of what could be a triple header with a Starlink launch set to lift off in just over 2 hours from now, and the Intuitive Machines 1 mission headed for the moon at 1:05 a.m. Eastern Time Thursday morning. You can see live views from both of those pads there on your screen now. Today's USSF-124 mission is a collaboration between the U.S. Missile Defense Agency, the MDA, and the United States Space Force Space Development Agency, or the SDA. On their behalf, SpaceX will be delivering 2 prototype satellites to orbit as part of the Hypersonic and Ballistic Tracking Space Sensor Program. When fully operational, the system will detect hypersonic, ballistic, and other advanced threats earlier than terrestrial radars, providing hypersonic threat tracking data to hand over to the U.S. Ballistic Missile Defense System. Now, in addition to the MDA payload, SpaceX will also deliver the final 4 Tranche 0 tracking layer satellites as part of its proliferated warfighter space architecture. But for now, here's a closer look at MDA's payload for today.
In the fall of 2009, a Delta II rocket launched off Florida's East Coast carrying 2 Missile Defense Agency Space Tracking and Surveillance System, or STSS, demonstration satellites. Designed to last 4 years, the STSS satellites operated for over 12 years, demonstrating birth-to-death ballistic missile tracking and missile defense system fire control quality data as a testbed to study new ways to improve ballistic missile tracking from space. Today, STSS data informs the development of future missile defense sensor capabilities, such as those on board the Hypersonic and Ballistic Tracking Space Sensor, or HBTSS. How do ballistic missiles differ from hypersonic missile threats? Ballistic missiles fly a predictable path and spend most of the time in space. Hypersonic glide vehicles, or HGVs, which can fly in excess of 3,800 miles per hour, can change direction and altitude and vary their speed in flight within the atmosphere, posing a severe challenge to today's missile defense system. Powerful radars on Earth can view in-flight objects only as far as the horizon allows, and only within specific corridors. A global constellation of HBTSS tracking satellites will ensure continuous access to missile threats from launch to re-entry, while providing fire control tracking to the missile defense system. Since tracking satellites offer a global presence and persistence, they can augment Earth-based radars and fill viewing gaps to provide coverage from missile launch to termination of flight. The 2 HBTSS prototype space vehicles will work in tandem with radars based on land and at sea, and recently deployed Space Force tracking satellites to demonstrate and study how they can track hypersonic threats and provide targeting data for intercept. This demonstration will inform the future Proliferated Warfighter Space Architecture, PWSA, for the Missile Warning, Tracking, Defense mission. Following these successful demonstrations, HBTSS will be part of a critical constellation of space sensors proliferated and operated by the Space Force. It will provide increased capability to track, target, and intercept hypersonic threats. As missile threats evolve, the Missile Defense Agency will continue leading efforts to improve the nation's defense capabilities.
Here at just under T-minus 12 minutes, the payload is healthy and all systems are a go for an on-time liftoff this evening. Weather and range are also green for today's T0. For now, let's take a closer look at the rocket on your screen. Now, Falcon 9 is a two-stage rocket and the first orbital class rocket capable of reflight. Since first taking flight in 2010, our Falcon 9 rocket has made 296 flights and delivered all sorts of payloads to orbit. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin M1D engines. Today is the 7th flight of the booster you see currently on the pad, and this Falcon 9 was first launched almost 1 year ago in March of 2023 on the Crew 6 mission for NASA. This will be the 8th National Security Space Launch, or NSSL, of a SpaceX Falcon 9 since December of 2018, and the second NSSL launch under the Phase 2 contract awarded by Space Systems Command in 2020. Now, the 9 engines you see on the Falcon 9 are shown on the screen there, and the Falcon 9 is actually named after the Millennium Falcon from Star Wars, and that number 9 is for the 9 Merlin engines that you see on the screen of the first stage. But there are actually 10 engines on the rocket as a whole. The second stage has a slightly modified engine on it called the Merlin Vacuum, or MVAC engine. Now, this engine has a larger diameter nozzle, which allows the second stage to be better adapted to perform in the vacuum of space. The first stage gets us out of the Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. Now, the large barrel structure with the pointed nose at the top of the second stage is the payload fairing, and it's composed of 2 halves made of carbon composite material that come together to protect the payload until we're in the vacuum of space. Now, here at T-minus 9 minutes and 38 seconds, the SpaceX team continues to count down towards our 13th launch this year. All systems are a go. And before we began the webcast, the SpaceX launch director pulled the members of the launch team and got a go for propellant loading and launch. So we are currently already loading propellant on the Falcon 9 first stage booster, as well as the second stage. The payloads continue to be healthy, and Falcon 9 team is tracking no issues on the rocket. Currently, the weather is green and the range is ready to support a T0 at 5:30 p.m. Eastern Time. Today, we have a greater than 95% probability of launch based on weather, but if for some reason we don't launch today, we do have a backup opportunity tomorrow at the same time. Now, if you are just joining us, today's mission is a collaboration between Space Systems Command, or the SSC, the U.S. Missile Defense Agency, and the U.S. Space Force's Space Development Agency. As part of this mission, SpaceX is delivering 2 prototype satellites to orbit as part of MDA's Hypersonic and Ballistic Tracking Space Sensor Program, in addition to the final 4 SDA Tranche 0 tracking layer satellites as part of its proliferated warfighter space architecture. Now, the SSC is the U.S. Space Force's field command responsible for acquiring and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space. For more on the SSC, let's take a listen.
The ultimate high ground has no ground. The satellites in orbit around our planet provide the critical infrastructure we use to defend and protect the security and prosperity of this world we all share. But space is no longer a benign environment. Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems Command, the time to act is now. The race is on.
Our adversary is out there. They are going to work every day, trying to work harder, smarter, faster than us. But we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering solutions to emerging threats, creating resilient space architectures we can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo, exploiting existing space architectures and capabilities in creative new ways, working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build, to deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments, to ensure that we can outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward, speak up, and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through any contingency or crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level to make space work for us all. At Space Systems Command, space starts here.
Here at T-minus 4 minutes and 40 seconds, all systems are currently a go for an on-time liftoff. Up next, the truss structure next to the vehicle, known as the strongback, will start to retract.
Strongback retract has started.
There you heard that call out for strongback retraction. Now you'll slowly see the clamp arms just below the fairing begin to open. And once the clamp arms are fully open, the strongback will begin to recline. And shortly after that, the strongback will fully recline in preparation for launch.
Stage 1 RP load complete.
There you heard the call out. The stage 1 propellant loading is complete, and we are still loading stage 2. Again, the vehicle is nearly fully loaded with propellant and will complete in a couple minutes here at the T-minus 2 minute mark. The range is green and ready to support. Weather is looking great with more than a 95% chance of a go. You can see the clear skies on your screen. And if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. Now, additionally, it's worth noting that at the request of our customer, we will not be showing views of the payload. So we will be ending the webcast just after the Falcon 9 booster makes its way back down to land around the T+8 minute mark into flight. And we finished the stage 1 RP1 load. Should be getting the LOX load call out here shortly.
Stage 1 LOX load complete.
There is that call out for stage 1 LOX loading complete. And we are just wrapping up stage 2 loading as well. And we should get that call out at the T-minus 2 minute mark. Again, you are looking at live views from Falcon 9 on Launch Pad 40 in Cape Canaveral, preparing for our USSF-124 mission. We are finishing up loading propellant and liquid oxygen onto the Falcon 9 first and second stages. We should be wrapping up.
Stage 2 LOX load complete.
There it is. That is the call out. We have finished loading propellant and liquid oxygen onto our Falcon 9. We're under 2 minutes to launch here. And again, you can see the condensation of that really cold liquid oxygen condensing with the humid air of Florida, and that venting that you see on the side is normal and expected. That is from the transporter erector liquid oxygen line. Now the next milestone will be at T-minus 1 minute, where the Falcon 9 internal flight computers will take over the count. Shortly afterwards, the launch director will give the go for launch, and Falcon 9 will be ready for launch.
Falcon 9 is in startup.
Falcon 9 is in startup.
This is the mission director. Go for launch.
There is that final mission director go. All systems are go for a launch of Falcon 9 and USSF-124.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go 124. Vehicles pitching downrange. F1D chamber pressure nominal.
Successful liftoff from Space Launch Complex 40 in Cape Canaveral, Florida. Love is in the air today, and now Falcon 9 is too. Our next milestone is at the T+1 minute and 12 mark, which will be max
Power
Q.
telemetry nominal.
And max Q is the moment of peak mechanical stress on the rocket. Great views of Falcon 9 there.
Mach 1.
We're coming up on max Q in just a few seconds.
Max Q.
There was max Q, and you could see the really cool view of Falcon going supersonic. You could see that little sonic boom in the live views there. And coming up in just about a minute here are
MVAC engine chill has started.
4 events in rapid succession. So the first will be main engine cutoff, and this is where all 9 of the Falcon first stage M1D engines will shut off in preparation for stage separation, which is when the first and second stages will separate, followed by second engine startup, which is when that Merlin vacuum engine of the second stage will start up to boost the payload to low Earth orbit. And then the last event is the boost back burn, where the Falcon 9 first stage will ignite to orient itself to head back to land. Now you can see these events will start in just about 10 seconds here with main engine cutoff.
Main engine cutoff.
Stage separation confirmed.
And back startup.
Stage 1 boost back startup.
There you saw and heard the confirmation of a successful main engine cutoff, stage separation, second engine start, and boost back burn start. You can see great views from the Falcon first stage. The grid fins will be deploying here shortly. And coming up is fairing deployment as well. And as a reminder, we won't see any live views from the second stage today, so we won't see the fairings deploy, but we will get confirmation of their deployment.
Fairing separation confirmed.
There you heard that call out for successful fairing deployment. Now, coming up next is the end of the boost back burn, which will be happening in just under 10 seconds here.
Stage 1 boost back shutdown.
There you heard that confirmation of the shutdown of the boost back burn. That is a good burn of the first stage. Again, you are watching a live webcast for USSF-124, a collaboration.
Vehicles are on nominal trajectories.
A collaboration between the Space Systems Command, the U.S. Missile Defense Agency, and the U.S. Space Forces Space Development Agency, delivering 2 prototype satellites to orbit as part of the Hypersonic and Ballistic Tracking Space Sensor Program, as well as the SDA's final 4 Tranche 0 tracking layer satellites. You can see our grid fins have deployed there, and these will help reorient that first stage as it makes its way back down to Earth. And you can see those puffs of gas, they're coming from the attitude control system, and that is nitrogen gas that is coming out. Now today we will be attempting to recover the Falcon 9 first stage back at landing zone 2. And in just a couple minutes, the booster will execute an entry burn followed by a landing burn. Now both of these burns are meant to slow the booster down rapidly before landing. And if we do have a successful landing today, it will mark the 272nd landing of an orbital class rocket. Now, in order to make its way back down to land for orbit, Falcon 9 does have 2 more burns to execute. We already performed our boost back burn, so coming up next is the entry burn in just about a minute. And this is where 3 of the Merlin engines of the first stage will reignite, and this will help slow the stage down as it re-enters the upper parts of the Earth's atmosphere. And then the third and last burn is the landing burn, and this is a single engine burn that brings the vehicle speed down rapidly in order to land back on Earth. You can see those nitrogen cold gas thrusters of our attitude control system along with our grid fins. Those are hypersonic grid fins, and there's 4 of them around the top of the Falcon first stage. We're coming up on the start of our first stage entry burn. This will be about a 20-second burn starting in just a few seconds.
Stage 1 entry burn.
There is the start of our stage 1 entry burn. And this is a 3-engine burn that's slowing that first stage down.
Stage 1 entry burn shutdown.
There is that shutdown.
Stage 1 FTS has safed.
Shutdown of the
Both
engines.
vehicles are on nominal trajectories.
And those callouts were that the flight termination system has been safed and trajectories are all nominal. Coming up next is our stage 1 landing burn in just about 30 seconds here as we come back towards the coast of Cape Canaveral. Again, there are 4 landing legs arranged around Falcon 9 first stage, which will deploy just prior to landing.
Stage 1 is transonic.
The vehicle is traveling around 900 miles per hour right now, so that landing burn is really going to slow it down.
Stage 1 landing burn.
There is the start of that stage 1 landing burn.
Stage 2 is in terminal guidance.
Super cool views of landing zone 2 approaching quick.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
Stage 2 FTS has safed.
Awesome views. There you have it. We have successfully made the 272nd landing of an orbital-class rocket. And with that successful confirmation of our booster landing that will bring today's webcast to a close, we'd like to give a heartfelt thank you to the United States Space Force for entrusting us with today's mission. And before you go, as many of you know, February is Black History Month. Since 1976, the United States has designated this month of February as a time to recognize and celebrate the critical roles that Black Americans had and continue to have in shaping our history. Diversity in backgrounds, mindsets, and perspectives is critical to making humanity multiplanetary, and this month we honor the achievements and contributions made by Black Americans throughout history. And every day we strive for a work environment that allows all employees to do their best work. So thank you for your interest in SpaceX and for tuning in. Again, today we are attempting 3 launches in within roughly 8 hours from 3 different launch pads across the country. So if you're interested in more launch coverage, be sure to check out spacex.com/launches and stay tuned for the upcoming Starlink launch here from Vandenberg, California in just under 2 hours. You can see the launch pad on the left of your screen, as well as the Intuitive Machines 1 mission planned for 1:05 a.m. Eastern Time at Launch Complex 39A at Kennedy Space Center that you'll see on the right of your screen there. Thanks again for tuning in, and we hope to see you soon.